Ever noticed your old bicycle develop a reddish-brown layer? Or opened a packet of snacks and thought, this smells off? That's not just time playing tricks, it's chemistry in action. What's really happening is a chemical reaction called oxidation, where substances react with oxygen in the air. It might sound subtle, but its impact is all around us, sometimes slow, like rusting, sometimes sneaky, like food spoilage. In this video, we'll explore how oxidation reactions shape our daily life. So, what exactly is oxidation? In simple terms, it's when a substance either gains oxygen or loses hydrogen in a chemical reaction. Let's break that down with a classic example straight from your book. Here, copper reacts with oxygen to form copper oxide, a black coating that often appears on heated copper. Because copper gained oxygen, it's said to be oxidized. But oxidation isn't just something that happens in a test tube. It's happening everywhere, when food browns, when metals corrode, even when your body converts glucose into energy. It's one of the most widespread and essential reactions in nature. Ever noticed how a shiny iron gate slowly loses its sparkle and turns a flaky reddish brown? That's not just dust or dirt, it's corrosion at work. Corrosion happens when metals react with oxygen, water, and pollutants over time. And when it hits iron, we call it rusting. Here's what's happening behind the scenes. Iron oxygen and water gives iron oxide hydrate. This reddish-brown layer is iron oxide, weak and crumbly. It peels off easily, exposing more iron underneath, and the process just keeps going. The result? Bridges weaken, cars corrode, machines fail. Billions are lost every year in maintenance. So the real question is, can we stop metals from rusting? Let's find out. Corrosion may be persistent, but so is chemistry. Here are some smart ways we protect metals from oxidation and extend their life. Painting or coating, this creates a physical barrier, preventing contact with air and water. Galvanization, iron is coated with a layer of zinc, which is more reactive and sacrifices itself by oxidizing before the iron does. Think of it as a chemical bodyguard. Oiling and greasing, often used for tools, hinges, and machines, this keeps moisture and air out. Alloying, we mix iron with metals like chromium or nickel to make stainless steel, which resists rust by design. And here's a fun fact, the green layer on copper pipes and the black tarnish on silver jewelry, that's also corrosion, just happening on different metals. So yes, with the right chemistry, we can fight back against rust. Ever torn open a bag of chips and thought, wait, this smells weird? That unpleasant odor is a sign of rancidity, and yes, it's another oxidation reaction at work. Here's what's happening. Fats and oils in the food react with oxygen in the air, breaking down into foul-smelling, unhealthy compounds. The food may look fine, but chemically, it's spoiled. So how do we keep our snacks fresh and safe? Antioxidants are added to slow down oxidation. Vacuum packing removes oxygen entirely. Nitrogen flushing, this is why chip packets feel puffed. They're filled with nitrogen gas to push out oxygen and protect the food inside. So next time your chips bag feels bloated, don't worry, that's not extra chips. That's smart chemistry guarding your snack. Oxidation reactions aren't just chemistry concepts, they're practical tools we use every day. Understanding them helps us create rust-resistant materials for safer bridges, longer-lasting cars, and stronger machines. Keep food fresh longer by preventing fats from going rancid. Build better batteries because redox reactions are what power your phone and electric car. And even explain how your body stays alive. Inside your cells, Oxygen reacts with glucose to release energy in a process called cellular respiration. Here's the reaction. Glucose plus oxygen gives carbon dioxide, water, and energy. That's right. Every breath you take powers a redox reaction keeping you going. Let's tie it all together with a quick recap. Oxidation is when a substance gains oxygen or loses hydrogen. Corrosion is slow oxidation of metals, like rusting iron or tarnished silver. Rancidity is oxidation of fats and oils, causing food to smell and spoil. We can prevent oxidation with paint, coatings, vacuum sealing, and antioxidants. And most importantly, oxidation reactions impact our homes, our food, our gadgets, and even our bodies. So the next time you see rust, smell stale oil, or check a food expiry date, remember, it's not just wear and tear. It's chemistry in action. Because even the smallest reactions can lead to the biggest changes.